Okay, some more application problems involving the Pythagorean theorem. Let's get rid of all this, shall we? Alright. I'm serious, it has serious applications, people. Alright, say this is a causal and there's a, you know what that is, y'all. A mode. Alright. Don't believe it's a castle? It's a castle. Okay. So I want to know height of here, castle, and this is dry land. All I need to do is station my guy at the top of the tower, throw down the string, and I catch it somewhere here. Me first wants to be smart. They told me the length of this was 25 feet, but I wanted to find out for myself. So I put the string here. And then I calculated the length of the string, because I had it all measured out, of course. And then I knew the height of the building. So the length of the string was 13. And I knew the height of the building here was 12. I could easily calculate the width of the moat. Once I get the width of the moat, which is 5, I can just use that. Now, so he throws it out to here. People are here watching, hey, the crowd, so they throw it out to here. I know the distance from here to the moat is 5. Now, here's where it gets complex. Now, what is that distance? Again, I have this marked out. I know this is 12. I have that marked out. How do I find that? Okay, those are the kind of applications where you start to apply the Pythagorean theorem. You know, this is 5, and all those other things come in. Of course, you have to give it this length and this. You know what that is. Okay, let's look at some other formulas after the Pythagorean theorem. The other thing, the quick little other thing you need to know about the Pythagorean theorem is there are 2 kinds of questions. One kind of question will ask you for the hypotenuse, which is the longest side. The other type of question was the second one I just showed you. Now the reason I keep using these numbers is because I know they're called Pythagorean triples, so it's going to work out anyhow. Square the legs would be equal to the square of the hypotenuse. Other Pythagorean triples I could have used, of course, is the most basic one, your basic 3, 4, 5. 3, 4, 5 triangle, a triangle with length of legs and the ratio of 3 to 4 to 5 will always be a right angle triangle. So it wouldn't matter what these numbers here would be, right angle triangle, and so on, and so on. Okay, now, moving on, they ask you to find one side when 2 sides are given. So, I know my relationship, a squared plus b squared, the legs, they add up to c squared, the hypotenuse. So, a quick mental math, square them up, and I get that. So look at an example for a question. Well, Roger was at home and he headed due east and due west, and he went to sea a certain distance, and then all of a sudden he got shot straight up in the air, and he was at A, and then he wants to know the quickest way to get back to B without going the way he came. Well, going the way he came, 40 plus 30 is 70. So I know going this way is going to be less than 70. Multiple choice questions. Do what did he? Okay, now, C, of course, the correct answer is that. I guess I should put 55 there. Let's be mean here. Ooh. Okay, so here are my answers, and there you go. Well, it looks like 50, it could be 55 or 45. 70. So funny. So 40 plus 30 is 70. That's how long he would need to go. But he would save 20 miles if he goes this way, which would be 50. A squared plus b squared, 40 times 40, 30. 30 times 30, add it up, 2,500. So that squared plus that squared equals that squared. So this must be 50, because I know 50 times 50 is 2,500. So that's the basic Pythagorean theorem problem. Sometimes they'll give you different things. Like they might give you, and oh, by the way, if the numbers don't check out, then it's not a right angle triangle, by the way. And that's, but I said I put some random numbers here. Is this a right angle triangle? Well, if it's a right angle triangle, a squared plus b squared has to be equal to c squared. 15 times 15, 225. 16 times 16, 256. 17 times 17, 289. So I know if I add these two together, I should get that. Well, it's not going to happen. Because this is already going way past that. So this cannot be a right angle triangle, 15, 16, 17. This number would have to be way bigger. I wonder what it is. Okay, 481. An interesting number. Is it a perfect square? I don't think so. So it would be an irrational number. But yeah, it would be possible, of course. So the answer here, of course, is C. A squared plus b squared equals c squared.